Hello friends, in this AV we are going to talk about the numericals of the chapter Calorimetry. We are going to take up the numericals of exercise 11A. In the previous AV you have already checked the solution up to number 6. So in this AV we will continue from numerical number 7. It says an electric heater of power 600 watt raises the temperature of 4 kg of a liquid from 10 degrees Celsius to 15 degrees Celsius. That means the rise in temperature is 15 minus 10, 5 degrees Celsius. In time 100 seconds. We have to calculate the heat capacity of the liquid and specific heat capacity of the liquid. We have written the given things. The power of the heater is 600 watt. Mass of the liquid is 4 kg. Change in temperature is 15 minus 10, that is 5 degrees Celsius or 5 Kelvin. The time is 100 seconds given in the question, and the heat capacity is power multiplied by time. We have the value of power as 600 and time is 100 seconds. So this delta Q comes out to be 60,000 joules. Now, using the formula delta Q is equal to mc delta T, where m is the mass, c is the specific heat capacity, and delta T is the change in temperature. We can find out the value of c, that is specific heat capacity. So c will be equal to delta Q upon m multiplied by delta T. So we have the values given to us and we just put the values. 60,000 divided by mass is 4 kg, change in temperature is 5 degrees Celsius. So after calculation it comes out to be 3000 joule per kg per Kelvin, and heat capacity is specific heat capacity multiplied by the mass. So specific heat capacity is 3000 and mass is 4 kg. So when you multiply it, you get it as 1.2 into 10 raised to the power 4 joule per Kelvin. Now let's take a look at the next numerical, that is number 8. It says 0.5 kg of lemon squash at 30 degrees Celsius is placed in a refrigerator which can remove heat at an average rate of 30 joules per second. How long will it take to cool the lemon squash to 5 degrees Celsius? Specific heat capacity of the squash is 4200 joules per kg per Kelvin. We have to find out the value of we have to find out the time taken to cool the lemon squash. So here we have written the given things. Change in temperature is final minus initial, that is 30 minus 5, 25 Kelvin. So delta Q is equal to mc delta T. So we calculate the value of delta Q. Mass is 0.5 kg. Specific heat is 4200 multiplied by change in temperature is 25. So it comes out to be 52500. I'll write it again, 52500 joules. Now time is equal to heat capacity divided by the power. So we have calculated the heat capacity and power is 30. So after division we get it as 1750 seconds. When converted to minutes it comes out to be 29 minutes and 10 seconds, which is the answer. Now question number 9 says a mass of 50 grams of a certain metal at 150 degrees Celsius is immersed in 100 grams of water at 11 degrees Celsius. The final temperature is 20 degrees Celsius. Calculate the specific heat capacity of the metal. Assume that the specific heat capacity of the water is 4.2 joules per gram per Kelvin. So I'll advise you to keep your textbook with you while we are writing the given things so that you can compare, because number 9 and 10 are of same type. So here we have written the given things. Mass of the metal, we are denoting it as M1, is 200 grams. Temperature of this metal T1 is 83 degree Celsius. Mass of the water M2 is 300 grams. Temperature of the water T2 is 30 degree Celsius. And finally it reaches a temperature 33 degrees. So final temperature is denoted as capital T. Now specific heat capacity of water is C2 and we have to find out the value of C1. So here, using this formula, the specific heat capacity of metal C1 is given by M1 C1 T1 minus T is equal to M2 C2 T minus T2. So we have to find out the value of C1. So the equation in terms of C1 becomes C1 is equal to M2 C2 T minus T2 divided by M1 T1 minus T. We have all the values here and we simply put the values and do the calculation and the answer comes out to be 0.378 joules per Kelvin. Now this was question number 9. Number 10 is similar to number 9. We have to do it in the same way, just that you will be finding out the final temperature capital T. Rest of the things are given to you. You will be using the same equation, same formula, same everything. Then just have to find out the value of capital T. Now question number 11 says 200 grams of hot water at 80 degrees Celsius is added to 300 grams of cold water at 10 degrees Celsius. Neglecting the heat taken by the container, calculate the final temperature of the mixture of water. Specific heat capacity of water is 4200 joules per kg per Kelvin. Here also we are going to use the same equation and we have to find out the value of capital T, that is the final temperature. So here we have written the given things. Mass of the hot water M1 is 200 grams. Temperature of hot water T1 is 80 degrees Celsius. Mass of the cold water M2 is 300 grams. Temperature of cold water T2 is 10 degree Celsius. So final temperature is what we have to calculate. So we know the formula M1 C1 multiplied by T1 minus T is equal to M2 C2 T minus T2. Now here, since we are talking about water only, so the specific heat in both the cases, that is C1 and C2, will be equal and they will be cancelling out each other. So C1 and C2 gets cancelled out. So we have, when you simplify this equation, to find out the value of T, we write this equation in terms of T. T is equal to M1 T1 plus M2 T2 divided by M1 plus M2. So after putting the values, the answer comes out to be 38 degree Celsius, which is the answer. So after this, let's try to solve number 12. Numerical number 12 says the temperature of 600 grams of cold water rises by 15 degree when 300 grams of hot water at 50 degree is added to it. What is the initial temperature of the cold water? So here we will write the given things as well. So this is what we have written. Mass of water M1 is equal to 300 grams. Temperature T1 is 50 degrees Celsius. Mass of cold water M2 is 600 grams. Change in temperature of the water is final temperature minus the second temperature, which is given to us as 15 degree. So final temperature is T degree Celsius. Now using the formula M1 C1 multiplied by T1 minus T is equal to M2 C2 T minus T2. We put the values again. C1 and C2 cancel out. M1 is 300, T1 is 50, T we will be finding out. M2 is 600, T minus T2 is 15 degree. So we put the values T minus T2 as 15. So after calculation it comes out to be 20 degree. So when the final temperature is 20 degree and change in temperature is 15 degree, so initial temperature would be final minus the change in temperature, that is 5 degree Celsius, which is the answer. Now the last one says 1 kg of water is contained in a 1.25 kilowatt kettle. This is the power of the kettle. This is given in kilowatt. We need to convert it into watt by multiplying it with 1000. Calculate the time taken for the temperature of water to rise from 25 degrees Celsius to its boiling point 100 degrees Celsius. Specific heat capacity of water, that is C, is 4.2 joules per gram per Kelvin. So here we have written the given things. Mass of water is 1000 grams. Change in temperature is 100 minus 25, that is 75 degrees Celsius or 75 Kelvin. Amount of heat energy required to raise the temperature, that is delta Q, is equal to mc delta T. This is what we know from the formula. So mass is 1000 multiplied by specific heat given to us is 4.2 and change in temperature is 75. So if you multiply, it comes out to be 3,15,000 joules. Now we know the formula that time is equal to delta Q divided by the power. So delta Q we have already calculated, 3,15,000 divided by the power of the kettle. They have given it to us in terms of kilowatt, that is 1.25 kilowatt. So we convert it to watt by multiplying it with 1000, which comes out to be 1250. So after division, it comes out to be 252 seconds, which if you convert into minutes, then it comes out to be 4 minutes and 12 seconds. So I hope this AV was useful and helpful to you. That's all we have in this AV for you. Thank you so much. Happy learning. God bless.